Hello, pre-calculus student. This video is for OpenStax Chapter 1.2 Domain and Range. Of course, it's domain and range of function. In 1.1, we introduced some basic function. We call them toolkit functions. So before we get into domain and range, we want to talk about some special names of functions because when we talk about domain and range of functions, we want to name them. So when we recognize a function, we want to give it a name so we can tell, oh, if it's this kind of function, so that the domain should be whatever like that. So the very basic function is called a linear function. It's kind of like a line represented by a line. And we know y equal to mx plus b is a line. So a linear function would be f of x equal to mx plus b. So if the function itself only have a x term as the input, then it is a linear function. A quadratic function would be what you have learned in Algebra 2 is it has a x squared term. And where the coefficient is a and a is not 0, then it's a quadratic function. So it could have a b term, it could have a bx term, and it could have a c term. And then in general, you can have x cubed, x fourth terms, and you would have something called a polynomial function. So you would have x something plus x, like x fourth, plus x cubed, plus x squared, plus something, plus a number. All these exponent of x are integers, positive integers, then you would have polynomial functions. Okay. And then the fourth one that we want to name them is called rational functions. What is a rational functions? Rational functions basically is when you are dividing two polynomial functions. So you would have a fraction line where the top, the numerator is a polynomial function and the denominator is a polynomial functions. Now this polynomial function is not a constant. So if it's a constant, then it doesn't count. So it has to be a function with x. Okay, so for example, 4x over 2x plus 1, so that is a rational function. So, or 4x squared minus 5x over 2x plus 1, that is also a rational function. The last one is called radical functions. So in the toolkit function, we have square root function, cube root function, right? So radical function are in general, just any roots, nth root. So n is a positive integer, so you just do a root of a function. So we call it the radical functions. So these are the basic one that you can recognize, and they're actually formed by the toolkit functions. Except for radical, you can say radicals are a lot more than from the toolkit functions. So how do I find domain of a formula function? If someone gives you a formula as a function, f of x equal to blah, blah, blah. So how can you tell what x makes sense? What is all the possible input? Because domain means all possible input, right? So what's the guideline of doing a question like this, of finding domain of a formula function? First is the easy one first. Oh, this is 3. If the function is a linear, quadratic, or polynomial function, or odd root radical function, odd root means when you see the radical here, this n is an odd number. We call it an index. But so if it's a cube root, a fifth root, that is called an odd root radical function. They have no domain restriction. So that means their domain is negative infinity to infinity. This is the interval notation of a set of numbers. The two things that we want to be careful when we do domain is actually just these two types. One is if there is a rational function, that means they have a ratio of two polynomial functions. So you want to exclude the number that would make the denominator 0. So anytime you solve for denominator equal to 0, you want to exclude that. The third is a even root radical functions. We know that when we do square root of a even number, like square root, fourth root, if this is an even number, the inside must be non-negative, right? It could be 0, but cannot be negative. So your radicand, we call the inside a radicand, the inside, this expression inside must be non-negative. That means all the things inside has to be greater than equal to 0. Okay, so you would say the denominator cannot be 0. Because the numerator can be anything, but the denominator cannot be 0. So you can summarize the guideline like this. And when you write the domain, it has to be in interval notation. So let's work on a few questions. First is the domain of x squared plus 3. So first things we will look at. What types of function is this? Oh, this is a quadratic, right? There is no ratio, there is no radical in it, so it's a quadratic function. So there's no domain, there's no restriction in the domain, so it's negative infinity to infinity. Any x can plug in. Question 2, example 2. Another function is 3x over 2x minus 1. Oh, we have a ratio of two functions. This is a polynomial function, and this is a polynomial function. So we don't care about the numerator, but we care about the denominator. So we want to make sure that 2x minus 1 not equal to 0, cannot divide by 0, right? So we say it's a rational function. So if you can name them, you would be able to, find domain clearer because of this kind of guideline. So 2x minus 1 cannot be 0 because we do not want the denominator to be 0. So 2x cannot be equal to 1. So you can solve it as if you're solving equation. X cannot be 1/2. So let's look at the number line. I have 1/2 here. My x can be any of these. The domain can be any of number, but not 1/2. So the interval notation will be negative infinity here, negative infinity up to 1/2, but not including 1/2. Union 1/2 again, excluding 1/2, and then all the way to infinity. So that is the interval notation. What about the third example? I have 2x minus 1, x squared minus 1. So again, it is a rational, remember, right? Because I have ratio of two polynomial function. Rational. So for rational, I only look at the denominator. So make sure that x squared minus 1 cannot be 0. Now, to solve this, we have to factor it. Okay, when you have quadratic, so x squared minus 1 can be factored as x minus 1, x plus 1 cannot be 0. How can this cannot be 0? So both of them cannot be 0, right? X cannot be 1. X cannot be negative 1. Okay, so we'll just do negative 1, 1. All of these two number cannot be in the domain, but all these can be, right? So then you would write from negative infinity, so this is negative infinity, up to negative 1, and then union from negative 1 to 1, so this is the middle one, and then union 1 to infinity. Okay, so pay attention. Some student may ask me, Miss Chan, if I factor the top, I have 2x minus 1. Can I cancel this x minus 1 with this x minus 1 in the denominator so that I only need to care about this? No. When you look at domain of a function, you look at the domain of the denominator cannot be 0 even before you cancel. Even if they can cancel, you cannot allow that. Okay. We'll talk about this a little bit more when we are in like chapter 3 point something, when we talk about rational functions. So, but for the time being, don't worry about the fact that you can cancel x minus 1 from the top. Even if you can cancel it, you still have to say that you do not allow this cancel number to be 0. So that particular number is actually called a point of removable discontinuity. The fourth example is find a domain of 1 over x minus 1 over x minus 2. So we have two rational functions. This is a rational. This is a rational. Although the top is 1, but if the bottom has a function, it is a rational. So it's difference of two rational. It's still rational. So we have to make sure that this cannot be 0. This cannot be 0. So you will say x cannot be 0. Also what? X cannot be 2. So do the number line. It cannot be 0, circle it. It cannot be 2, circle it. So all these can be the domain, right? So then you would write negative infinity to 0, union 0 to 2, union 2 to infinity. Okay, the fifth example. So finally we have gone through the first one, we have gone through the rational function, so we are into radical function. So both of these are radical functions. So let's look at the first one. This is obviously a square root. If there's no number here, it's a square root. So we say the inside cannot be negative, right? Because this is an even root radical function. So we have to make sure that this is all positive or 0. So 5x is greater than equal to negative 4. X is greater than equal to negative 4 over 5. Okay. So on a number line, you have negative 4 over 5. All the input has to be greater than this, including this number. So you would say, use the square bracket, negative 4 over 5, and all the way to infinity. The last one is a odd root radical. What do we say in the guideline? We say if it is a odd root radical, you can actually take any number of a cube root or any odd root. So there's no domain restriction, negative infinity to infinity. Okay, so and then we have find a domain range from a graph function. So if it's a graph, what you can do is look at all the points. So basically look at all the points. Where did it go? So horizontally, that would be the domain. Vertically, that's the range. So you look at how much it goes. So I'm going to do two examples. One is like a function that start at x equal to 2 and then end at x equal to 8. You can tell that horizontally, this is domain. And then you can say it's from 2 to 8. For 8, it's a solid dot, so it'll be square bracket. Vertically, how much does it go? Oh, it's actually just between 6 to 8. Do you see? So you say this is the domain, and the range is what? From 6, so this is the lowest number, up to 8, but doesn't include 8. And then the next one is a parabola, kind of a parabola segment. So we have horizontally, how much does it span? It stop here, right? Stop from here. And all the way, all the x value is between these number. Now, in case there's an arrow, and I think in the worksheet there's some arrow, then you would say, oh, go to infinity. But these has stopped set it to n. So for the lowest number is -3, and including -3, the highest x value is 2, not including 2. So that's what we do. That's domain. Range is what? How high does it go? So we would say it's actually all the way from here and then stop here, right? So the lowest number is actually -5, including -5. Highest number is 4, including 4. So both square brackets. So that's how you read off domain and range from a graph. So then the next video we'll talk about piecewise function. I think we have domain of application also, but it will be in the next video.